diameter are zipping around our planet right now. They include pieces of glass broken off of solar cells, paint chips from spacecraft, and debris from rocket booster engines. And in deeper space, there's more danger from pebble-sized meteors called micrometeoroids.
A small piece of dust can crack glass, it can penetrate metal, it can pulverize plastic. And that does happen in space all the time.
But perhaps an even more deadly danger, not at all solid, lies in wait: radiation. The devastating effects of this invisible energy have been witnessed on Earth in the aftermath of the atomic bombs of World War II and the nuclear fallout of Chernobyl. Distressingly, our own life-giving sun spews out streams of poisonous radiation.
So realize that we've been protected in this cradle. We've been protected by the atmosphere of the Earth. Magnetic field of the Earth gobbles up most of the flares from the sun to create the aurora borealis. In outer space, you get the aurora borealis coming right at you. There's no ozone layer, there's no magnetic field to protect you. It's just you and the harshness of outer space.
At our home planet's distance from the sun, roughly 90 million miles away, several hundred million solar particles pass through each square inch of space every second around our Earth.
There's high energy particles streaming from the sun all the time. But every now and then there's an extra dose of these particles. The sun burps up high energy radiation. That's bad too. That level of radiation is never good for one's DNA.
Sunspots flare up these extra doses of energy, like a battery of cannons bombarding the cosmos.
There's no way to know that they're going to be here before they arrive.
Unfortunately, there's still a risk of radiation even as we get farther from the sun. That's because another invading energy lurks. Known as galactic cosmic rays, they hail from the distant alien worlds of exploding stars and black holes.
Galactic cosmic rays are particles that are traveling at speeds very close to the speed of light. Even a single particle of iron slamming into your body can have the effect of a Major League Baseball at 100 miles an hour. They can be devastating.
Although heavy iron particles are rare, outside of the protection of a spacecraft, such as when an astronaut performs a spacewalk, thousands of galactic cosmic rays do penetrate the body every second. Every 24 hours, the galactic cosmic rays and solar particles attack a space traveler with as much radiation as a surface dweller on Earth receives in 6 months. The human body won't immediately feel the impacting radiation, but in sufficient quantities, it can be noticed. Even with eyes closed, the particles spark flashes when they strike a space traveler's retina.
The flashes are not blinding, and you have to ask yourself, did I see something? And then you say, oh, yes, I did. And its appearance is a little different from time to time.
However, the human body does feel the shock of this bizarre weightless existence.
I think that the most dangerous thing going into space is the loss of gravity. Weightlessness causes almost every system in your body to start changing. And it doesn't stop changing until you get back onto a world where you're pulled down again by its gravity.
One of the first casualties of zero gravity is a space traveler's sense of direction.
What's up and what's down? Very good question. And first of all, it's whatever you want it to be. If you want this to be up, that's fine. But if you want this to be up, that's just as good.
Most travelers will suffer from motion sickness for the first few hours, or most likely, days.
It's just one of those things that you ought to resign yourself to facing, that everyone is very likely to feel a little bit disturbed in terms of orientation.
Here on Earth, scuba divers floating underwater experience the nearest sensation of prolonged periods without gravity. It is for this very reason that aspiring NASA astronauts train to live and work in a gravity-free environment by subjecting themselves for up to 6 hours at a time in a large water tank.
Now, scuba equipment, you still experience the forces of gravity, but it doesn't feel like it because your whole body is uniformly buoyed by the water that holds you up.
And except for the visual cue of air bubbles floating to the surface, swimming underwater can mimic the sensation of disorientation. But as time passes in the weightlessness of space, the human body senses it no longer needs to resist the force of gravity and begins shedding muscle and bone mass.
When you're in space, your body thinks you might as well be lying in bed. And so if you're not careful, your body will atrophy.
To counter this, each day in space, an astronaut needs to exercise. The legs are especially vulnerable because they are seldom used. In this world, the arms and hands do most of the work to move the body around.
What would be the toughest thing to get used to might very well be just how you live in space, where you can't walk across the room. You have to float everywhere you're going.
The lack of gravity also slows down the digestive tract, which can cause problems at mealtime.
Your digestive system stops. You can't eat, you can't drink until you can start digesting again. And that can take anywhere from hours to days.
Worse still, zero gravity and radiation can combine in an especially sinister way.
In space, the immune system is not as effective as it normally is. And many of the bacteria and viruses that we normally can withstand become more virulent.
Additionally, bacteria can grow up to 50 times faster, and any virus brought on board could mutate into a never-before-seen predator thanks to the ever-present radiation. All these difficulties prey on space travelers in just the first few hours or days. And what about journeys that need more time? It only gets tougher. The universe is an unforgiving place. It's open to only the boldest adventurers, those who have the mettle to trek deep into an environment swimming with toxic hazards, and unafraid to stray far from the safe and familiar.
We take it for granted that clothing is flexible and machines work in room temperature because implicitly or explicitly they're designed for that. You go into the depths of space. If you're facing the sun, it could be hundreds of degrees Fahrenheit. If you're facing away from the sun, it could be hundreds of degrees below zero.
Down here on Earth, you take so much for granted. You know, we're out here, sunshine, the fresh air all around you. Up there, you're in a closed ecosystem. You have to supply all the human needs that the Earth just, automatically does for us. You have to hope that the integrity of the hull stays together so you don't have rapid decompression, quick suffocation.
The same reality exists for a submarine gliding deep through the ocean. It provides a life-preserving barrier to protect its inhabitants from a surrounding alien world.
If there's damage to the spaceship, air leaks out, you die. Damage to the submarine, water gets in, you die. So the isolation both physically and personally, between the two, seem quite parallel.
The potential for a catastrophic mishap lurks.
When you're out in the middle of the ocean, you have only yourself and your colleagues to rely on. And the same thing applies in space.
Things have to hold up. You can't come back, you can't run to the hardware store, you can't fix the thing with some part that you didn't bring along, and you're stuck with human ingenuity, the tools you brought with you. And out there in space, you truly are just removed from mankind. It is isolation like I've never felt before.
Liftoff. We have liftoff.
Often, our efforts to explore space have been analogized to the great explorers of the 15th and 16th century. The first to sort of cross the oceans, going to unknown territory, having to bring all their supplies with them, not knowing if they'll ever return. And I think there's a lot to say about that analogy, but there's a point where it breaks down badly. When Cortez landed in South America, when Columbus hit the Caribbean, there was still air there for him to breathe. All right? There were fruit on the trees. Suppose the Apollo 11 astronauts, Neil Armstrong and Buzz Aldrin, landed on the moon and, like, the engine broke.
Okay, Houston, we've had a problem here.
What do? Nothing. You just die. There's not sort of an engine tree that they can pluck parts from to repair their ship. So the hazards are vastly greater to human health in space exploration than traveling anywhere on Earth's surface.
There won't be any service stations in case you break down, run out of gas, or need something to drink.
One of the challenges of space exploration is either carrying along with you all the supplies you need, water, food, oxygen, or finding some way to manufacture that en route or at your destination. We're not there yet. We don't know how to do that yet. And so one hazard is if something goes wrong and you run out of food and water and shelter, that's bad. You'll die.
Every sip, every drop of water is precious. On a space voyage, there will be no such thing as a shower. The only option will likely be a wet cloth. This is quite a change from the 130 gallons of water each American consumes in just one day. The cuisine on board would take some getting used to as well.
For a few days, you can take fresh fruits and fresh vegetables, carrots and apples and things like that. For the longer missions, though, you have to have storable foods that can, stay for long periods of time without spoiling and going bad.
And yet, astronauts agree that enduring the myriad of risks is a small price to pay for the chance to witness the wonder of the cosmos in person.
1500's 2.3. I know how they felt because they report things like, well, you could hold up your finger and you could block out the Earth with your thumb. And it kind of gave them an entire new perspective of how amazing this little blue marble the Earth is and how precious it is in this vast solar system.
That experience changed me forever, and I think it would change anyone that could possibly have that experience in the future.
However, the length of future voyages might limit the range of experiences available to space travelers. Distances in our vast universe can defy comprehension. If our sun were the size of a basketball, our Earth would be the size of a pea. If they were placed in Central Park, the nearest star would be another basketball almost 5,000 miles away in Hawaii.
One of the prerequisites you might have for a space mission is that you're alive when you arrive at your destination. So you'd want your space missions to be small compared with the life expectancy of a human being. And right now, that pretty much limits us to the planets and possibly comets and asteroids, if we include those as places we might visit.
The brutal, scathing landscapes of the solar system's inner planets, Mercury and Venus, do not make for tempting vacation destinations. Temperatures on Venus can exceed 900 degrees Fahrenheit, and the crushing air pressure is equivalent to being submerged in 3,000 feet of water. That leaves all points further out from the sun for potential exploration. But even trips to our closest attractions will still take several months or even years. About 139 million miles separate the orbits of Earth and Mars. But since each body circles the sun at different speeds, the distances with respect to each other change continuously.
The problem with going to Mars is that Mars and the Earth only line up about once every 2 years.
With current chemically propelled rocket technology, a flight leaving from Earth for the Red Planet in 2018, when the two bodies are on the same side of the sun, could take 104 days, less than 4 months. After a 40-day stay, the return trip would require a little more than 6 months. That's an entire year to make one round trip. But a voyage departing in 2031, when the Earth and Mars are on the opposite sides of the sun, would demand about 20 months, nearly 2 years of travel time. That's 1 to 2 years away from any lifeline. Comets, those oversized dirty snowballs, swoop close enough to Earth to accommodate a round trip lasting as short as a few months.
Find some comet that's on its way into the sun and ride it. And watch the coma grow and the tail form. And watch the sun first slowly, but then rapidly get larger and larger and larger. You swing around the backside and come out. It's got to be the most fun tour of the solar system you can come up with. It'd be dangerous because particles of the comet would fly up and hit you in the face and things. So apart from all that which would kill you, it would be a fun trip.
Just beyond the orbit of Mars, asteroids fly within range of a few years round trip from Earth. Future travel agencies might arrange cosmic versions of extreme vacations by exploiting the unique environments of these miniature planets.
They put you on a sled and slingshot you into space in such a way that the weak gravity of the asteroid will hold you in orbit but won't pull you back down again. Would be a great ride.
3 times farther away than Mars, the orbit of Jupiter, with its crowded moon system, offers dozens of diverse visions. It may prove tempting for future travelers, but a round trip could take 5 years. Saturn is nearly twice as far as Jupiter, and the thought of decade-long trips might be too much to bear. But there are technologies that can slice the time it takes to visit Mars to just a few days. For mankind ever to venture into the depths of the cosmos, endeavor to bathe in the light of an exotic star, or even just a voyage to the suburbs of our own solar system, we'll need to find a way to travel much, much faster. What's the fastest we could travel? Nothing yet observed by science moves faster than the speed of light, 186,000 miles per second.
The speed of light is the ultimate velocity in the universe. It's Einstein's cop on the block. The speed of light is so fast that you could go around the Earth 7 times in just 1 second. For you to jump to the moon at the speed of light, you could reach the moon in about 1 second.
Compare that to the 3 days it takes to get there with current technology. The problem is that we can't travel at the speed of light, or really anything even approaching it.
Take the fastest thing we have ever sent anywhere and ask, how long will that take to reach the nearest stars. That would take 50,000 years.
And that is using current chemical propulsion, which maxes out at about 40,000 miles per hour. The same power source we use to lift our rockets off of the planet. But getting us to Mars faster than a few months' time would require a different kind of propulsion. There are a few ideas for how to propel us to velocities closer to the speed of light, which would be fast enough to get us anywhere in the solar system in under a day, or even to the nearest stars in less than a decade. One such theory echoes an ancient earthly propulsion device, wind pushing a sail.
It was Kepler, that great astronomer, who first wrote down in his notes the possibility of using sails to sail in outer space.
Light streaming from the sun mimics gusts of wind in outer space. This solar wind is what creates a comet's tail as it nears the sun. However, sunlight scatters in all directions, and as the distance from the sun doubles, its power reduces by a factor of 4. With a little help from the moon, there is a manner in which light could be focused in one direction.
If we have a battery of laser cannons on the moon, firing in synchronization at a solar sail, we may be able to propel it to about perhaps half the speed of light. Now, lasers do diffuse with space. For example, if I have a laser on the Earth and I shine it to the moon, it does not create a spot on the moon. The spot is about 5 miles across on the moon. These sails, however, would be huge. Now we're talking about astronauts, perhaps spending months in outer space, designing a sail hundreds, maybe even thousands of miles across, sufficiently light and durable in order to capture light from a battery of laser beams on the moon.
But solar sailing limits space vessels to destinations within our solar system. One alternative gets around this problem by tapping into hydrogen, the most abundant element in the universe, as a propulsion source.
My favorite design to take us to the stars is the ramjet fusion engine. The ramjet engine has a gigantic scoop in the forward direction that gobbles up hydrogen gas as it moves in deep space. It collects the hydrogen gas and then fuses it, just like the sun, and shoots out a huge stream of ions out the other end. And on paper, it looks fantastic. On paper, it looks as if a ramjet fusion engine could go on forever, simply using up the hydrogen that is found naturally in outer space.
Unfortunately, scientists have not yet been able to achieve a hydrogen fusion reaction capable of propulsion in tests. But another potential fuel source, one that seems to come right out of science fiction, has already been created in laboratories. It's called antimatter, and it's the opposite of all that we know.
For example, think of the world on the other side of the looking glass. Just like in Lewis Carroll's Alice in Wonderland, we physicists have wondered, is there another universe on the other end of the looking glass? A parity-reversed universe where left becomes right, right becomes left. In an anti-universe, charges are reversed. So positive charges become negative, negative charges become positive, and when they meet, they create a burst of energy. So if this universe on the other side of the looking glass were made out of antimatter, and I were to touch this other universe, I would destroy most of the New York City metropolitan area in a burst of energy. So the conversion of antimatter and matter to energy is 100% efficient. It is the ultimate engine. But there is a catch. There's always a catch. Even though we can create anti-atoms in the laboratory, the cost is stupendous. It would bankrupt the United States of America to create a teaspoon of antimatter. However, it would only take a few grams of antimatter to take us to Mars, and perhaps several teaspoons of antimatter to take us to the nearby stars.
But for us to ever visit a distant star or another galaxy, we need something stranger than even Alice could ever dream of, peering through her looking glass. Scientists continue the quest for a propulsion method to carry us ever deeper into space. But even achieving light speed won't allow us to get very far.
Light's fast, but the universe is huge. So even if we could ride on a beam of light, if we wanted to cross the galaxy, the way they do in all the science fiction programs, it would take 100,000 years to do it.
And even at light speed, traveling to the nearest galaxy would take several million years. And if light speed is the ultimate speed limit of the universe, it seems we're doomed to confinement in our galactic neighborhood.
What we're desperate for is some new understanding of the fabric of space-time that will allow us to somehow warp it, distort it, so that you can take shortcuts. And of course, that's what they do in Star Trek when they turn on their warp drives. They want to get from one side of the galaxy to the other. All they do is invoke the warp drive that warps the fabric of space, and then they take a little shortcut right there. They cheat, basically.
Everybody knows Einstein's famous dictum, you cannot go faster than the speed of light. However, there's a footnote to it. You see, Einstein left open the possibility that you can fold the fabric of space and time itself so that you effectively take a shortcut through the universe. Think of a carpet. If you want to go across the carpet, that's the old-fashioned way. You can also get a lasso a table on the other side of the carpet, and then drag the table toward you so that you collapse the space in front of you. In a nutshell, Einstein says the bigger the mass, the bigger the bending of space and time. If you can concentrate enormous amounts of energy at a single point, comparable to that of a black hole or a huge gigantic star, you are literally warping the fabric of space and time. You simply hop across to the nearby stars. So in other words, you did not really go to the stars. The stars came to you because you are compressing the space in front of you.
The massive amount of energy or mass needed to create such a warped curvature of space seems beyond comprehension and perhaps beyond human capability. There may be an alternative. Physicist John Brandenburg is developing a theory in which a starship of the future could achieve faster-than-light travel, not by manipulating a vast area of the universe, but rather by manipulating only the area around the starship. The trick is to have a starship imitate a curious particle that so far only exists in theory. It's called a tachyon.
It's a particle with a different twist. Light itself always moves at the same speed. Tachyons, on the other hand, can go infinitely fast. They just can't go slower than the speed of light. They look at the speed of light as a lower speed limit that they cannot violate.
If they do exist, tachyons can outrun the speed of light because they have what physicists recognize as imaginary mass. An imaginary value can be visualized in the spin of a struck tennis ball. Its spin can cause it to bend and move in a manner that an observer might not expect to see from its initial point of contact. In the same way, a tachyon is unseen by the universe and can break its speed limits. Brandenburg proposes altering the space-time surrounding a starship with a powerful electromagnetic field so that the ship moves through space like a tachyon. It would operate like a stealth aircraft, invisible to radar and unseen by radar operators.
So if one can achieve this control of the space-time around this ship, one can essentially make it an imaginary object. In a technical way, that means it's moving faster than light. You're basically disconnecting yourself from the rest of the cosmos.
It could grant the traveler the ability to go anywhere in the universe in the blink of an eye, as if a multitude of doorways suddenly appeared.
A doorway you step into and then you step out somewhere down the hall so fast that it didn't seem like you had time to move anyplace. That's an imaginary connection in space-time. And you've changed yourself, not space-time.
No one may know how fast or even where such a space vessel could travel.
Which door to go into, which door to come out of. That's the trick.
But voyaging through the Hall of the Universe isn't possible without first overcoming one of its fundamental forces, the one that shackles us to our home planet.
Getting away from the Earth's gravitational field. That's the first thing that we have to do.
10, 9, 8, 7, 6.
For an object to break away from Earth's gravitational pull,
2, 1. We have ignition and liftoff of NASA's new
it must
Horizon
achieve a
space
velocity of 17,500 miles per hour. That's fast enough to streak from New York to Los Angeles in about 8 minutes.
There's no other way to do it, at least that we have now, other than brute force.
While a theoretical space elevator can climb away from Earth's gravitational pull, a rocket must outrun it with the brute force provided by the explosive chemical reaction of burning fuel.
Chemical power is what drives today's rocket engine. Every time you burn something, that's chemical power. Every time a rocket engine ignites, that's chemical power. Every time you start your engine in your car, you're using the chemical energy stored in the gasoline.
The fuel alone can burden a spacebound craft with up to 90% of its total weight.
If you're carrying all the fuel you'll ever need, then most of the effort of the first ignited fuel is to lift the unburnt fuel into orbit. It'd be like trying to drive from New York City to Los Angeles on one tank of gas. Well, you would need a tanker truck behind you. And most of the energy to accelerate the tanker truck is going in to just move the fuel that's in the tanker truck.
The space shuttle, its rockets, and the fuel they're carrying weigh a staggering 4 million pounds. And nothing short of a bone-rattling eruption could push it up and away from Earth.
Well, Brent, looks like your long wait is over. We wish you all the best luck in the world. Godspeed, and we'll see you back here in about 2 weeks.
A journey into space today means that space travelers must ride a controlled detonation into the sky.
Whatever the vehicle weighs, we have to generate about 1.5 to 2 times that thrust in order to get it off the surface of the Earth.
To get the space shuttle up to speed demands 7 million pounds of thrust. To put that into perspective,
if you can imagine me holding a 1-pound ball in my hand, if I'm holding it here and I'm holding it steady, I am exerting a pound of thrust on that ball. So if I lower it down, I'm clearly not exerting a 1 pound. If I pick it up, I'm exerting more than a pound. So you have to have a little more thrust than you do the weight, obviously, or you won't go anywhere.
How a rocket moves can be illustrated with a blown-up balloon.
This works almost like an engine nozzle. Now I can hold it in place, and you can control it. You can let it go. And what we do is we try to eject as much mass through that throat as we can. And as it expands out, the back end, that expansion or that pressure pushing that way pushes the vehicle this way.
When today's astronauts climb aboard for their journeys on the space shuttle, they're hitching to giant containers housing that necessary mass. Millions of pounds of highly combustible hydrogen and oxygen wait to be ejected. It only takes a spark.
The main engine starts 6 seconds before takeoff.
3,
the whole shuttle shakes. It feels like it wants to just rip itself out of the launch pad.
Liftoff of Space Shuttle Endeavour, expanding the International
It shudders,
Space Station.
and you think, oh my gosh, that's an awful lot of force, about 1.5 million pounds of thrust. It's kind of surreal. It's like, this can't really be happening. If it's something you've been wanting to do for years and years, and it's really happening. It's like riding a man-made earthquake. You've spent several million pounds worth of fuel to get to the first 2 minutes of flight, and then the solid rocket boosters come off. That's like a train wreck when those things come off. It almost feels like you're just accelerating faster and faster and faster as you burn all the fuel out of the big main tank. So for the next 6 minutes, you're accelerating up to a point where you're finally feeling about 3 Gs, 3 times the force of gravity of acceleration. And so now it almost feels like there's a big gorilla sitting on your chest.
A drag racer who accelerates from 0 to 100 miles per hour in 2 seconds will feel G-forces similar to those experienced by astronauts.
As the vehicle keeps accelerating and you're watching the speed tick by in thousands of feet per second until you get to 25 times the speed of sound. Then there's a cutoff, and then everything's floating. And now you're in space. So space isn't very far away. It only takes about 8 minutes and 30 seconds to get there.
The next model for venturing into the great beyond and reaching new worlds will begin first with a visit to an old friend. Although not quite yet a space elevator, NASA's mission to return to the moon builds on the idea of Earth orbit as a base for farther voyages. NASA's Constellation program, a successor to the legendary Apollo program, aims to plant boots on the moon by 2020. 2 separate rockets form the foundation of the plan. The unmanned Ares 5 rocket, towering taller than a football field standing on its end, will carry the lunar lander, supplies, and an Earth departure rocket into orbit, where it will wait for the astronauts. The Ares 1 rocket will deliver the crew to orbit aboard a capsule. If you think science has already uncovered every dangerous, strange, and extraordinary phenomenon under the sun, think again. We are right now in the midst of the greatest era of space discovery. And many of the weird and wondrous things are happening right here in our own cosmic backyard.
Our solar system is a really fantastic place. You know, we've now found other planetary systems, and we've not yet found anything quite like our solar system.
You've joined us on a magical journey through the 7 wonders of our solar system. We first head for the orbit of Saturn. Number 7, Enceladus. It's midnight, November 2nd, 2009. NASA's Cassini spacecraft orbits the planet Saturn. Its cameras capture something bizarre on one of its outer moons, named Enceladus. Most of the solar system's moons are geologically dead, and looking at the glistening icy surface of its south pole, Enceladus seems like a peaceful world. Then suddenly, without warning, gargantuan geysers of water and ice eject from cracks on its surface.
Enceladus is a fantastic moon of Saturn. Though it's relatively small, Enceladus is different from the volcanism that's here on Earth, where hot magma, which is basically molten rock, comes out from underneath Earth's surface. Enceladus has water, basically, liquid water coming out and freezing, and so it's called cryovolcanism.
The Cassini spacecraft flies directly through the energetic plumes that blast hundreds of miles into space at 1,400 miles per hour.
Enceladus has really caught our imagination recently because we see geysers coming out of the South Pole. We haven't seen anything like that on any of the icy moons in the outer solar system. So something is going on in Enceladus, and it's active, and we want to know why.
Scientists have counted at least 30 geyser jets spouting from narrow geological fractures called tiger stripes, located along Enceladus's south polar region. A new infrared map of the area reveals warm surface temperatures. The heat emanating from the tiger stripes may be due to the upwelling of water vapor that propels the jets. One of the few other places to witness this truly fascinating wonder is on Earth. At a freshly groomed ski slope, or on a movie set.
Wow, look at this snowmaking machine. It's like a geyser from Enceladus. All these ice particles and water droplets freeze when they encounter the outside air. And the expanding gases also help cool the droplets and freeze them. In the case of Enceladus, heated liquid water in a cauldron below the surface goes squirting out through some vents in the south polar region. And when that water comes out and encounters the cold surrounding space, it freezes, forming snowflakes and ice particles, much like the ones coming out of this snowmaking machine. So wow, I might as well be on Enceladus right now.
Scientists think there must be two internal heat sources driving this icy volcanism on Enceladus. One source could be radioactive elements that decay and heat up the interior, thereby keeping the water in a liquid state. The second could be tidal heating.
Suppose Enceladus is like this squishy balloon. Now, Enceladus orbits Saturn in a slightly elliptical, eccentric orbit. So sometimes it's closer to Saturn, sometimes it's farther away. When it's close to Saturn, Saturn's gravitational pull creates a greater tidal stretching of Enceladus than when Enceladus is farther away. That leads to a rubbing of the interior materials and a release of energy. This tidal friction, as it's called, helps melt the interior of Enceladus and keep the water in this molten or partly molten state.
One mystery is how much water actually exists beneath the surface. Could the miniature moon be hiding an underground ocean?
We infer that there is a liquid ocean because there needs to be a source of water to power these geysers. The ocean may not extend under the entire globe of Enceladus. It may be just beneath these regions where the geysers are going off, but there has to be a significant reservoir of liquid water beneath the surface of Enceladus.
If liquid water exists beneath the surface, it could be teeming with organic molecules. These, along with relatively warm temperatures, are the essential ingredients for creating life.
It would be incredible if we were to find life, primitive life, underneath the surface of Enceladus. We don't expect complex creatures such as ourselves or rabbits or turtles, but even primitive bacterial or microbial life, independent of life on Earth, would be one of the greatest discoveries ever.
Enceladus actually orbits within another wonder of the solar system. Number 6, the rings of Saturn. The rings, named in alphabetical order as they were discovered, are among the most dazzling sights in the sky.
The Voyager spacecraft first visited Saturn quite a while ago. And now with the new images provided by Cassini, it's like putting on a pair of 3D glasses for the first time to be able to see with great detail what's inside Saturn's rings.
Among the 7 main rings, it's estimated that the gaseous planet has thousands of ringlets comprised of 35 trillion tons of ice and dust, containing roughly 26 million times the amount of water on Earth. Yet their origin has eluded scientists for centuries.
We really don't know their origin. They may consist of material that never had a chance to form into a moon because of gravitational influences of Saturn itself. Or maybe they're a moon that wandered too close to Saturn and got broken up, shattered by the tidal gravitational effects of Saturn. Or possibly even a comet came in too close to Saturn and got tidally disrupted by Saturn's immense gravitational field.
What's even more remarkable is that scientists have counted 62 moons embedded in Saturn's rings. New images indicate that these tiny satellites have taken the rings to new heights. August 11th, 2009. A rare equinox photo of Saturn shows her rings edge on to the sun. The image unveils a shocking fact. The bright bands that once appeared to be solid and flat actually contain ridges spanning from a few feet to mountain ranges taller than the Alps.
When you look at Saturn's rings from a telescope on Earth, they look completely smooth and featureless. But now we see that there are regions where the ring particles are piled up into what you could call mountains, which can be several miles high.
But how are these mile-high mountains formed? NASA's Cassini mission actually captured images of embedded moons sweeping through Saturn's rings, causing them to twist and ripple, creating ever-changing patterns. In Saturn's A ring, the outermost of the large bright rings, the moon Daphnis has carved a vertical peak, which is over 2.5 miles high.
The moons are interacting with Saturn's rings in such a way as to either pull material slightly above the ring or below the ring as the moon goes round, because its orbit doesn't quite match that of the ring itself.
The ring system surrounding Saturn is a spectacular sight. But on a neighboring planet, there's a very different scene, one almost too monstrous to believe. It's number 5 in our countdown of the 7 amazing wonders. A raging storm that's nearly 3 times the size of Earth. As we continue our countdown of the 7 wonders of our solar system, we leave behind number 7, Enceladus, and number 6, the rings of Saturn. We now blast off to number 5, Jupiter's Great Red Spot. This mother of all storms is about 3 times the size of Earth.
We don't know exactly how the red spot formed. It's been there as long as we've been looking, as far back as the 1650s. So it was there before we started really paying attention.
The Great Red Spot is actually an ancient storm that's been spinning wildly for centuries. the supersized vortex towers 5 miles above the planet's cloud tops and dwarfs any storm system on Earth.
The 400-mile-an-hour winds measured in Jupiter's Great Red Spot are faster than some of the most powerful winds measured in tornadoes here on Earth. Yet tornadoes on Earth only last maybe a few tens of minutes, or at most a couple of hours, whereas Jupiter's Great Red Spot's been going strong for at least 400 years, and it's 3 times the size of Earth. Now that's one storm you don't want to get caught in.
Most tropical storms in Earth's southern hemisphere spin clockwise as our planet rotates. But on Jupiter, the Great Red Spot follows an unearthly path.
The Great Red Spot, which is in Jupiter's southern hemisphere, rotates counterclockwise. It's anticyclonic. And that's because it's a high-pressure system, unlike the low-pressure systems here on Earth associated with storms. So when you have a high-pressure system, the airflow is naturally the opposite to that of a low-pressure system.
The origin of this long-lived storm has baffled astronomers. But now, science may be on the verge of unraveling its stormy secrets. The Hubble Space Telescope recently snapped images of 3 smaller storms on Jupiter called white spots. Within 3 years, the 3 white spots merged to form one Earth-sized storm. Then, the unexpected happened.
Over the course of only about a week, the storm turned from white to bright red. It's now known as Oval BA, or sometimes Red Junior. Why it turned red and exactly how that happened is still a mystery.
Astronomers now suspect a similar merger may have also created the Great Red Spot. And like Red Junior, the ferocious storm may have originally been white. But as its speed grew faster, it began dredging up material from deep in Jupiter's atmosphere. One of the compounds could actually be a form of sulfur.
We don't fully understand why the red spot has its characteristic brick red color, but probably there are chemical compounds which are reacting with the sunlight and are giving it this color.
Astronomers have been closely monitoring the Great Red Spot. And in the last decade, they have detected an astonishing change.
We've been watching the Great Red Spot shrink and actually become rounder for some time now. Who knows if it's going to persist for another 400 years or maybe disappear entirely.
The Great Red Spot is by far the biggest storm in our solar system. But after leaving Jupiter, we head about 200 million miles in the direction of the sun and have a close encounter with another barely believable wonder. Number 4, the asteroid belt. Scientists want to know more about the origin of this cosmic junkyard of wayward debris, which is left over from the formation of the solar system.
For a long time, we thought that maybe there had been a planet there that got pulverized and we were just seeing the debris of some major catastrophe. But we pretty much now realize that a planet never was able to form there. The gravitational pull from Jupiter and the other planets just made it impossible for material to coalesce into a planet.
We traverse through 100 million miles of rocks, some as small as several feet, others bigger than cities. The belt probably contains millions of rocky pieces. Yet if all the asteroids were condensed into one boulder, it would be smaller than our moon.
We can start to learn more about the history of our solar system by studying the small bodies in our solar system, the asteroids. We'd like to know how they moved around, how are they affected by the giant planets, and what is their ultimate fate? What will happen to them?
Popular movies have portrayed the asteroid belt as a cosmic obstacle course, a place where spaceships dodge enormous boulders that constantly collide and jostle for position before hurtling down from space to destroy planet Earth. But has Hollywood gotten it wrong? How congested is the asteroid belt? That's what one viewer wanted to ask the universe. So Joel T. from Kansas City, Missouri texted us. Have movies accurately represented what the asteroid belt actually looks like?
Thanks for the question, Joel. I know this is a bit shocking, but the asteroid belt hasn't always been portrayed terribly accurately in most blockbuster movies. If you were orbiting an asteroid inside our solar system's asteroid belt, you wouldn't be able to see big cratered surfaces of other asteroids flying right next to you. In fact, they probably look just like distant points of light. That's because the average separations between most asteroids in the asteroid belt are much larger than their actual sizes, so they really just look like dots.
In fact, an average distance between two asteroids can be 1 million miles. However, among this spacious sea of odd-shaped rocks exists a round ball. Ceres is the biggest asteroid in the solar system. The awesome 600-mile wide rock contains a fourth of the entire mass of the asteroid belt.
Most asteroids in the asteroid belt are lumpy-shaped, kind of like potatoes. But Ceres is different. It's actually big enough to have enough mass, to have enough gravity, to crush itself into a round shape.
Because of its spherical shape, Ceres was upgraded. Scientists recently listed it as a dwarf planet, the same designation given to Pluto.
The modern view of Ceres is that it's not big enough to be called a genuine planet, but it is big enough for it to have formed a roughly spherical shape, but not big enough to be a true planet.
This fourth wonder not only holds unique artifacts from the formation of our solar system, it also harbors potential weapons of mass destruction. Many asteroids have escaped the confines of the asteroid belt. And at any moment, one of these rogue space rocks could repeat history. And no one will live to talk about it. So far, our journey through the 7 wonders of the solar system has taken us to the geysers of Enceladus, the rings of Saturn, and the Great Red Spot on Jupiter. Now, we continue to travel through the fourth of our wonders, the asteroid belt. This band of leftover debris has even made it to the big screen. And the rocks Hollywood is obsessed with the most are those that escape the asteroid belt and head for planet Earth. Near-Earth objects, or NEOs, are cosmic rocks like asteroids or comets, which strike Earth almost every day.
We're really very interested in near-Earth objects, objects that pass across the orbit of the Earth around the Sun, because occasionally they can and do collide with the Earth. And if they're big enough, they can cause vast destruction here on Earth.
On April 14th, 2010, cameras caught sight of a 3-foot fiery asteroid streaming over the Midwestern United States. Fortunately, the cosmic rock broke into tiny pieces before hitting the ground. But in the past, large asteroid impacts have created gigantic craters and even triggered mass extinction events, like the Chicxulub asteroid that killed off the dinosaurs.
Over the last billions of years, Earth has been hit many times by asteroids of various sizes. The impact that occurred roughly 65 million years ago that perhaps wiped out the dinosaurs was an example of something that was about 6 miles across. It slammed into what is now Mexico and caused huge global ramifications for the Earth.
A number of new space surveys are currently tracking all near-Earth objects that are large enough to destroy a modern city, or even worse, ignite a global catastrophe.
We know of most of the objects that are larger than a mile that can intersect the Earth's orbit. And so the effort now is going into finding these sort of stadium-sized objects that, while not completely devastating to the entire Earth, would be a huge deal if they hit the Earth.
As we leave behind the asteroid belt, we chart a course to the next of our 7 wonders. Number 3, Olympus Mons, the largest volcano in the solar system. As we approach the planet Mars, we immediately catch sight of this mammoth mountain.
The base of it is about almost 350 miles across. That's as though the base of the mountain were from Los Angeles to San Francisco. So even though it's so high, the slope is very gradual. You would barely know you were climbing a mountain. It's not like a steep volcano. It's just, it's a smooth, low slope, but it just goes on forever.
Olympus Mons is located in the Tharsis Bulge, a region on the red planet that's home to other massive volcanoes. If you climb the 13 miles to its summit, you could take in a view of the very edge of the Martian atmosphere.
Olympus Mons is several times higher than the highest mountains on Earth. And its base is hundreds of miles across. And it's been formed over the last billions of years by eruption after eruption after eruption, which has slowly surfaced it with successive layers of lava.
100 million years ago, hot lava rivers poured down from its peak to cover millions of square miles of the red planet. Today, Olympus Mons is 100 times the volume of Earth's largest volcano, Mauna Loa, located on the big island of Hawaii.
Olympus Mons got so much larger than anything here for, well, a number of reasons. One is certainly there was just a lot of volcanic activity. A second is that Mars's gravity is much lower. You weigh a lot less on Mars. So as the mountain built up, it didn't compact back down. It was able to build up to a pretty huge volcano without collapsing.
The third, and perhaps most important reason why Olympus Mons is so huge is that Mars doesn't have plate tectonics, the movement of crustal plates that rest on top of the molten interior of bodies, such as Earth.
Olympus Mons grew to such a big size because of the lack of tectonic motions on Mars. The hot spot from which the lava, the magma, emerged remained at one location, allowing more and more material to build up and create a super mountain, a super volcano.
Mars is now presumed to be geologically inactive. But is the volcanic beast really dead, or merely a sleeping giant? The European Space Agency's Mars Express mission recently captured the highest resolution images ever taken of the planet's lava flows. Some flows date back 115 million years, but others are only 2 million years old. And on geologic timescales, that's very recent, which suggests there still may be some volcanic activity.
If we look at the surface of Olympus Mons, We see especially that there are lava flows which have very few craters on them. And so we know that those lava flows are perhaps 10, 20 million years old at the oldest. But the eruptive activity has been going on until the relatively recent past, if not right up until the present day.
Olympus Mons may have once produced vast amounts of lava, but its hellish heat paled in comparison to the current temperatures of number 2 on our countdown of the 7 incredible wonders of our solar system. This may look like a ball of flames, but its surface is an ocean of 10,000-degree plasma with waves, winds, and massive eruptions as explosive as 1 billion tons of TNT. Our next wonder of the solar system has been Earth's best friend and foe. It's bathed our planet with heat and energy, but it's also blasted us with potentially deadly, highly energetic particles and waves. We now navigate around number 2, the sizzling surface of the sun.
The surface of the sun is really quite chaotic. It's always boiling and bubbling. In particular, there are hot cells of gas that come out from the interior up, radiate their energy, cool, and then come back down. So this convection, as it's called, this boiling motion, similar to what you see in a boiling pot of water, is occurring near the surface.
We have never been able to look at the sun's surface up close until now. At this very moment, a new collection of satellites is capturing images of our home star. These unprecedented movies make you feel like you're an arm's distance away from touching the sun's visible surface, called the photosphere. This is where solar storms and other violent phenomena occur.
The surface of the sun, if you were somehow able to go there and protect yourself, is an incredibly noisy, hot, and violent place. There are temperatures, thousands of degrees. There are continuous magnetic storms that create huge, basically thunder-like sounds.
In this new movie, NASA's Solar Dynamic Observatory recorded a prominence. This is a relatively cool, dense cloud of plasma that sits suspended above the solar surface, supported by magnetic forces. As seen here, prominences can occasionally rip free and jet into space.
Our sun has an incredibly powerful magnetic field. But every now and again, those field lines become connected to hot spots on the surface of the sun. And as the gas and plasma boils inside the sun, those magnetic field lines can disconnect or break, releasing huge bursts of energy. And these throw up giant blasts of plasma that come out along curious-looking arcs. But these are actually following the magnetic field lines around the sun.
Eruptive prominences can occur in tandem with another solar ejection that can deliver a double punch if directed at the Earth. NASA's Solar and Heliospheric Observatory, or SOHO, recently took dramatic movies of coronal mass ejections, or CMEs. These massive bubbles of hot ionized gas contain up to 10 billion tons of solar material. They shoot out into space at speeds of several million miles an hour.
Coronal mass ejections are incredibly powerful storms. They can be as massive as 1 billion H-bombs, just huge amounts of energy. And sometimes those big blobs of plasma strike the Earth and lead to beautiful northern lights, aurora displays. They can also be very harmful to the Earth.
When large coronal mass ejections are blasted toward Earth, they can trigger geomagnetic storms. These blobs of ionized particles can damage or even terminate satellites, as well as fry our electrical grids. What's more, they're extremely hazardous to astronauts when outside of the protection of a spacecraft.
The CMEs generate X-rays. So if you're out in space, you would get quite a dose of radiation if you were in one of these CMEs. Luckily, our atmosphere absorbs most of the X-rays, and we don't experience the bad effects here on the surface of the Earth. If you're high up in an airplane, above most of the atmosphere, then you can get a larger dose of radiation if there's a large flare hitting the Earth.
These latest images are chilling reminders that our sun's surface is a force to reckon with. And things may really heat up on our home star in the very near future. Solar activity runs through an 11-year cycle. In 2013, our sun will be at the peak of this cycle, called the solar maximum. At this time, the surface of the sun could create the perfect storm.
The sun has had in the past big solar storms that have knocked out power grids and our communication satellites. There will be more storms. They might happen at any time, or they may not happen, you know, in our lifetime or even in the next millennium. We just don't know. That's one of the exciting things about studying the sun, is trying to be able to understand and maybe even predict the storms that we see in the sun.
But one thing a solar storm can't destroy is number 1 on our countdown of the 7 wonders of our solar system. It's the 5th largest planet. 1/10 of its surface is permanently covered with ice, and its hot interior has been churning up enough magma to keep volcanoes erupting for billions of years. The exploration of our cosmic neighborhood climaxes with a touchdown on number 1 of the 7 wonders, Earth.
The Earth, without a doubt, is the single greatest wonder in the solar system. The Earth is so perfect for our existence. There's liquid water, there's an atmosphere, there's comfortable temperatures. It's just a great place.
Earth, the 3rd planet from the sun, is brimming with breathtaking beauty. Unlike any other body in the solar system, liquid water covers nearly 2/3 of its surface. Its continents inherited a diverse landscape, and it's the only planet confirmed to support life in all its amazing forms.
Earth has a number of different features that make it truly unique in our solar system. For one thing, it's not boiling hot, and nor is it freezing cold. It's just at the right distance from the sun to be a very moderate temperature that supports life. For another thing, it's not completely a water world, nor is it completely a dry desert either. It's got just the right mix of land and ocean to support a wide variety of species.
Science is now getting closer to solving the mystery of how life got started by retracing the steps of our planet's formation. $4.6 billion years ago, in the swirling disk of debris left over from the formation of our newborn sun, gas and dust particles began to clump together they eventually formed large boulders made of rock and ice that we see today as asteroids and comets. For millions of years, these bodies collided and coalesced to form planets. During this birthing process, Earth acquired some special properties. One unique feature on Earth is abundant liquid water. It is thought that the earliest volcanoes spewed out massive amounts of steam, which condensed into rain and supplied the planet with water. But recently, new sources of water have been suggested.
Some of the water might have come from comets, or some of the water might have come from an outer belt of asteroids that was rich in water. In other words, some of the water could have come from the rocks that made the Earth near the end of this era of heavy bombardment.
And water appears to be a key component for the origin of life. It was previously theorized that life began in a primordial soup, a warm pond containing energy and atmospheric elements to make amino acids. However, the most recent pioneering research makes a strong claim that the Earth's own chemical energy and rich proteins seeped up through hydrothermal vents deep under the ocean. Over time, this mixture jump-started life by producing living cells.
We know that liquid water is essential to life, and life probably got started in a water environment. Whether it's in the deep ocean at the volcanic vents or in a shallow pond, we don't really know where and how precisely life got started here, but it did, and it's the only planet that we know where life actually exists.
Regardless of how life started, a fortunate event made it possible for complex creatures to evolve. About 3 billion years ago, ancient underwater bacteria began to use water, carbon dioxide, and the sun's energy to produce carbohydrates in order to survive. This process, called photosynthesis, injected vast amounts of oxygen into seawater and eventually our atmosphere.
A huge step happened in evolution when the Earth got polluted with oxygen. We didn't start with a rich oxygen atmosphere, but later the oxygen atmosphere that developed on Earth, basically from photosynthesis, allowed life to get a lot more complex.
After a few billion years of planetary and biological evolution, the first plants and animals emerged from water onto land. It's estimated that modern humans came onto the scene a mere 200,000 years ago. And with our evolution came the technological revolution of the planet. From ancient man-made monuments to bustling metropolitan cities, human beings changed the way Earth looks on the ground and from space.
The Earth's surface has started to be modified very significantly by cities, by human activity. We're part of the Earth. We've created all these changes on its surface. So the Earth's geology, in some deep sense, has been radically altered by the appearances of cities, by the appearances of all the things that we do on the surface. And that's something that's remarkable and which, as far as we know, is not happening anywhere else. Certainly it's not happening anywhere else in our own solar system.
Our cosmic tour has taken us to 7 wondrous sights. The icy, geyser-laden moon Enceladus, Saturn's sensational rings, Jupiter's great red spot, the largest volcano, Olympus Mons, the mysterious asteroid belt, and our stormy sun. But this unforgettable adventure would not have been possible without our home planet, Earth, a place